Lesson 6, Beyond the Unit Circle. Up to this point, we've primarily been using angle measures and values that are defined within the unit circle, a circle that has a radius of 1. However, we should be able to apply and use these trig functions for anything, not just within the unit circle, because we should be able to also use and establish the concept of similar triangles to go beyond the unit circle. So here, suppose that x and y is the point on the terminal side of an angle measure theta, plotted in standard position, which lies on the circle x squared plus y squared equals r squared. This is demonstrated to the right. Then the circle has a radius of r, and x is equal to r times cosine of theta, and y is equal to r times sine of theta. The reason for this is if you look at this circle here, we would be able to establish that sine of theta is equal to y over r, the opposite over the hypotenuse. Therefore, if you solve for y in this case by multiplying r to the other side, you should be able to take sine of theta equals y over r and isolate y by multiplying r over to get r times sine of theta is equal to y. The same concept will hold true for cosine, where if you multiply r to the other side, you get r times cosine of theta is equal to x. What this means is that if you are dealing with any xy coordinate, that does not necessarily mean that the x coordinate is going to be what cosine of theta is equal to, and the y-coordinate is not what sine of theta is equal to. That is only true on the unit circle where the radius is 1. If you are dealing with any coordinate x and y, the x-coordinate is actually equal to the multiplication of r times cosine of theta, and y is equal to the multiplication of r times sine of theta. You can then also come up with ratios concerning cosecant, secant, tangent, and cotangent using similar values here. Just in this case, any instance where we had 1 before on the unit circle, that is now replaced with r. Since this is still a right triangle that is defined with two legs of sides x and y, you can also represent r by using the Pythagorean theorem. R is the hypotenuse side of this right triangle as it lies across from the right angle measure, which means that we can write this as r squared is equal to x squared plus y squared, or that r is equal to the square root of x squared plus y squared. That means that you can write any of these ratios that we've established using r by using the square root of x squared plus y squared instead.